Hi guys, today we are going to look at the second algebraic way to solve systems of equations, and that method is called elimination. To eliminate something. What does it mean to eliminate something? Well, it means we want to get rid of a variable, right? We want to get rid of something. Eliminate means to get rid of. In this case, we're going to get rid of a variable so that we can solve for the other variable. Now, the way we know we're going to use elimination is that the first step is to make sure that all like terms are lined up together in the equations, meaning we have all the y's in a line, we have all the x's in a line, we have all the numbers in a line. So if I happen to have an x equals or a y equals, I probably am going to use substitution. But elimination, I want to make sure these are all in a line. Okay. Now, the next part of elimination is to look for something we call inverse coefficients. Now, what an inverse coefficient is something like 3x and negative 3x. Okay. Well, if we have 3x and we have negative 3x, when I combine those together, what do I get? I get 0, right? So the point is that if we have inverse coefficients, we will be able to eliminate, using elimination, a variable. So we want inverse coefficients to eliminate. Now here's the problem. Not always are we going to have inverse coefficients just written there. So sometimes if we can't find the inverse coefficient, we're going to make them inverse coefficients by multiplying. So let's look at an example. Let's say I had 2x and 4x. To make these inverse coefficients by multiplying, I would need to multiply the 2x by negative 2 so that it became negative 4x. And so then I can combine, negative 4x and positive 4x to eliminate them. Okay, so that's what it means by multiplying. We just multiply the coefficient by what it needs to get to the inverse coefficient. We'll look at some examples. Then the step 3 is we're going to eliminate one variable and solve for the other. We're going to use the new value from 3, the one we just got, to find the other variable's value. This is just like the last step with substitution, and then write as an ordered pair. Okay, so let's try an example. Okay, and on this, I actually think I'm going to change the numbering just based on how I do this. I agree with 1, 2. Well, I'm okay, I guess. I would probably call this 3, this 4, and this 5. I order it a little bit different than I used to. Okay, beside the point. Step 1 says to make sure that the equations are lined up with their variables stacked together. So we have 3y plus x equals 4. And I just want to make sure that my y lines up with my y, my x lines up with my x, and my constant lines up with my constant. So they literally look like the exact same. Now, what I want to do is I want to eliminate a variable. Okay. Now here are my options. I could choose to eliminate y, but to eliminate y, since this already has a positive 3, this y would need to be a negative 3. And because to eliminate x's, if I wanted to choose to eliminate x's, and it doesn't matter, I'm actually going to do both ways. I'll have you just try one with me and then we'll look at the other one. If I wanted to eliminate the x, this is a positive 1x, this is a negative 2x. So what I would do is I would multiply this by 2. So this is positive 2 while this is negative 2. And you get to choose. Now here's what I'll tell you. If I happen to see that one of my variables already has a positive and a negative, so this x has one part that's positive and one that's negative, oftentimes that's going to be the one I'm going to choose to eliminate. That way I don't have to multiply by a negative number. Okay, So in this example, I'm going to choose to multiply this top equation rather, by positive 2. Okay, so the top equation becomes 6y plus 2x equals 8. Please remember you need to multiply every term, including the answer, by that 2. Now I'm just going to rewrite the other one. We had y minus 2x equals 6. Now what I need to do is add the two equations together. And in adding the two equations together, here's what you'll notice. We get 6y plus y equals 7y. And then we get positive 2x and negative 2x. Well, the whole point was to eliminate the x's, and they are gone now. A positive 2x and a negative 2x eliminate. And then we have equals 8 plus 6, which we get 14. So now I'm down to one variable. Look how easy this is going to be to solve. So I'm going to divide both sides by 7, and I get y to be 2. Now, just like yesterday, when y equals a value, I can take what y equals and plug it back into one of my equations. It does not matter which equation you choose. So maybe I'll choose the top one. The top equation was 3y plus x equals 4. Now, I got what y is. I know y is 2. So in place of y, I'm going to put a 2. So really I have 3 times 2 plus x equals 4. That means I get 6 plus x equals 4. And now I can subtract 6 and get x equals negative 2. So my final answer, the ordered pair that I have, is negative 2, comma, 2, x, y. So x is negative 2, y is 2. And that's how you solve using elimination. Okay, I want you just to watch for a second, and I'm going to move this to the side. And I'm going to repeat this process, but remember how we said we could eliminate either variable? So let's look at what that might look like. Okay, so remember the equation was 3y plus x equals 4, and y minus 2x equals 6. And to begin with, we chose to eliminate x. Well, if I wanted to choose to eliminate y, I would multiply this entire equation by negative 3. Okay, so the equation I'm multiplying, well, let's see, this first equation didn't change, but the equation I'm multiplying becomes negative 3y plus 6x, because remember a negative 3 times a negative 2 gives me a positive 6, equals negative 18. Now what I'm going to do is I'm going to add these two equations together. And you'll see that now we have the y's where they're inverses. So before we eliminated x, now I'm eliminating y. You do not have to do both methods. I just want to show you either way should work. Now when I add these together, we get positive 7x equals negative 14. I'm not sure why I wrote the positive sign. We don't really need that. Okay. And then I'm going to divide both sides by 7 to get x equals negative 2. And now I can take what x equals. I can take the fact that x equals negative 2, and let's plug it into one of my equations. Let's go back to that same 3y plus x equals 4. So 3y plus x equals 4. And in place of x, I'm going to put negative 2. So 3y plus negative 2 equals 4. Well, so that's really 3y minus 2 equals 4. So I'm going to add 2 to both sides. And we get 3y equals 6. And I'm going to divide by 3. And notice we get y equals 2. It's the same ordered pair. We just solve for the variables in a different order. So negative 2, 2 is the answer. Okay, what I would like you to do is I would like you to hit pause and try this example, the one that says negative 3x plus 7y equals 19. All right, now looking at this problem, if we talk about elimination, I don't have one number I can multiply negative 3 by to give me 10 or to give me negative 10. So there's not going to be a really easy way to eliminate my x's on this one. So what about my y's? Well, this is a positive 7. This is a negative 14. What if I multiply this top equation by 2 so that this becomes a positive 14y, then it will eliminate with the negative 14y. I think that's going to be our best bet. So let's do that. Let's multiply this top equation by positive 2. So the top equation becomes negative 6x plus 14y equals 38. 2 times 19. Remember, we have to distribute to everything. And the bottom equation doesn't change. 10x minus 14y equals 2. Notice now they're inverse coefficients. One's positive, one's negative. That's exactly what we wanted. So now what I'm going to do is add the two equations together. This gives me positive 4x, the y's eliminate, equals 40. So now I just divide both sides by 4, and I get x to be 10. And now what I can do with that x equals 10 is substitute this back into one of my equations. It does not matter which one. So let's just choose that top one. Negative 3x plus 7y equals 19. And remember, we want to replace the x with x. So we get negative 3 times 10, replacing the x with x, plus 7y equals 19. So negative 30 plus 7y equals 19. Add 30. 7y equals 49. Divide by 7, and we get y equals 7. So the answer to this system of equations is an ordered pair 10, 7, x, y. 10, 7. How'd you do? Okay, give this third one a shot. See what you can come up with. It's a little bit different. See how you do. All right, hopefully you had a chance to try this third one. Now what you should notice is with these x's, I don't really have one number I can multiply either of them by to get the same number, meaning I can't multiply 4 by anything to get 5. Well, I could. Anything that's a whole number. Nor do I have anything where I can multiply 2 by to get 9. So sometimes we have to multiply both equations. Okay, so let's think about our x's. If I wanted to eliminate my x's, what number do both 5 and 4 go into? They go into 20. So since they both go into 20, I would need to think about what I could multiply this top equation by to make the x's 20. And I could multiply this top equation by 4, and that would give me 20x. But then I would need to multiply the bottom equation by 5 to give me 20x down there, or negative 20x down there. So that's one option. Now, I don't have to use that option. What I could do is I could eliminate my y's. And I need to think about what number what number they both go into, 2 and 9. And that's 18. So I could multiply this top equation by 9 and this bottom one by 2, and those would eliminate because they already have one positive and one negative. So it's really up to you. Now I'm going to go back to what I had before. So let's multiply this top equation by 4. So we get 20x minus 8y equals 40. And now I'm going to multiply the bottom equation by 5. So we get negative 20x plus 45y equals negative 40. Now you'll notice, and this was the whole point, that we have inverse coefficients. One positive, one negative. Okay, so now what I'm going to do is add these two equations together, because adding a positive and a negative together is going to eliminate that term. So my x's are going to go away. And now what I'm left with is 37y equals 0, 40 minus 40. And when I divide by 37, I get y equals 0. So there's one of my variables. Now I need to take this y equals 0 and go back into one of my equations. It doesn't matter which equation. So let's just choose the top and plug it in. So remember, the top equation is 5x minus 2y equals 10. And we're going to substitute in place of the y. So we would have 5x minus 2 times 0 equals 10. Now I'm going to solve. So I get 5x minus 0 equals 10, which means 5x equals 10. I'm going to divide by 5, and we get x equals 2. So now I have my solution to the system of equations. I have the ordered pair 2, 0. All right, you guys, have a good day.